For 8 classes, we have built an understanding of what AI is, how machines learn, and the 4 kinds of problems they solve. You now think about AI the right way. But there's a moment in every learner in 39 Tao's journey where understanding has to meet doing an 8 to 12, where you stop reading about the kitchen and finally pick up a knife. Today is that moment. We are going to write real code in the language that runs almost the entire world of AI, Python. You do not need any programming background, and you do not need to be an A2020 maths person and A20201. If you can write a shopping list in a clear order, you can write a program. By the end of this class, you will understand what a program actually is. You will make the computer speak with your very first line of code. You will store and use information in variables, and you will run a small program of your own. This is the bridge from knowing about AI to building it. Let us cross it. Here is our path for today. First, why Python is the language of AI. Second, what a program really is. Third, print N8512, your first line of code. Fourth, variables that store your data. Fifth, using variables together. And sixth, running code and reading errors without fear. Let us begin. Let us start with the obvious question. Of all the programming languages in the world, why Python? The first reason is that Python reads almost like plain English. Where many languages surround you with brackets, semicolons, and cryptic symbols, Python was designed from the start to be clear and readable. A line of Python often says exactly what it does, and 8200 you can frequently guess what a program means before anyone explains it. That readability is not a small nicety. For a beginner, it is the difference between fighting the language and thinking about your actual problem. The second reason is the one that matters most for us. Python is the language of AI and machine learning. Nearly every important AI tool, library, and framework, and 85 to how, the ones that train models, handle data, and power the systems we have studied, and 85 to how, is built for Python and used through Python. When researchers publish a new breakthrough, the code almost always arrives in Python. So learning it is not a detour from AI, it is the direct road into it. The third reason is the ecosystem and the community. Because so many people use Python, there is a vast collection of ready-made tools you can simply pull in and use, and an enormous community that has already asked and answered almost every beginner question you will ever have. You are never coding alone. So the takeaway, Python is readable enough for a complete beginner. It is the dominant language of AI and machine learning, and it comes with a huge ecosystem and community behind it, and 8112, which is exactly why it is where your hands-on journey begins. Before we write code, let us be clear about what a program actually is, because the idea is simpler than most people fear. A program is just a list of instructions for the computer to follow, written down precisely, and carried out in order and 8 hotel 1, from the top of the file to the bottom, one line at a time. That is genuinely the whole concept. It is like a recipe, do this, then this, then this. The computer does not improvise, and it does not guess your intent, it does exactly what each line says in the exact sequence you wrote them. The one thing a computer demands that a human cook does not is precision. A recipe can say N8 to Watuhandi, add a pinch of salt and 8 to Watuhandi on IDI, and plus 2 to understand. A computer cannot. Every instruction must be spelled out exactly in a form the language understands, because the machine follows your words literally and A220 to have, not the meaning you had in your head. No must. This is why beginners hit small errors constantly. And it is not a sign you are bad at this. It is simply the computer being relentlessly literal. The good news is that this literalness is also what makes programming learnable. Because the rules are fixed and the order is predictable, you can always trace exactly what a program will do by reading it line by line as the computer does. There is no hidden magic. If you can follow a sequence of clear steps, you can already read a program. So the takeaway, a program is an ordered list of precise instructions. The computer runs top to bottom, exactly as written N8200, a recipe for the machine N8200, and the discipline of being precise, not any special talent, is what programming really asks of you. Now let us write our very first line of real Python and 808 whole, the traditional first step for every programmer in history. The command is print. When you write print, followed by round brackets, and inside those brackets, some text wrapped in quotation marks, Python will display that text on the screen. So the classic first program is simply print, open bracket, quote, hello, world, quote, close bracket. Run it, and the computer prints the words, hello, world back to you. It looks tiny, but something real just happened. You gave the machine an instruction, and it obeyed. Let us name the parts, because they will appear everywhere from now on. The word print is a function and 812 Paul, a named, ready-made action that Python already knows how to perform. The round brackets are how you call that function. That is, tell it to run. And the thing you put inside the brackets is what you hand to the function to work with, an 812. Here, the text you want shown. That pattern, a name followed by brackets containing what to act on, is one you will use thousands of times. Notice too, the quotation marks around the text. They tell Python N8200 ORIS, treat what is inside literally as words to display N821 or 8200 ORIS rather than as commands to run. Text wrapped in quotes like this is called a string and 82520 wall, a string of characters and 82525. And it is how programs hold any kind of written information, from a greeting to a name to a whole message. So, the takeaway, print is a function that displays whatever you put in its brackets. Quotation marks mark that content as a string of text to show literally, and writing print of hello. World is the small but genuine moment you make the computer do your bidding for the first time. A program that only prints fixed words is limited and 82112. Real programs need to remember things. That is what variables are for. A variable is a named box in which you store a value so you can use it later. You create one by choosing a name, writing an equal sign, and giving it a value an 8212 whole. For example, name equals, in quotes, Sarah. From that moment, the name and A2I2, name A2I2, refers to the value and A2I2I2, Sarah A2I2 and wherever you use it, Python substitutes what is inside. So print of name would now display Sarah, not the word name. You have given a piece of information a label you can refer to. Think of it exactly like a label box on a shelf. The label is the variable any tiny 9, san name. The contents are its value. You do not have to remember where the value physically lives in the computer, Indy9, SES memory, and 80125. You just refer to it by its label, and the machine fetches it for you. This is the whole reason variables exist. They let you store something once and reuse it by name as many times as you like. Variables can hold different kinds of values, and this matters. A variable can store a piece of text, like a name, a whole number, like an age, or a decimal number, like a price. The value in the box has a type, and the type decides what you can do with it, and 8212, you can do arithmetic with numbers, for instance, but not with a name. We will explore those types properly in the next class. For now, simply note that the box can hold text or numbers. So the takeaway, a variable is a named box that stores a value and ATU-POLV. You create it with a name, an equal sign, and a value, and then use it by its label, an ATU-POLV. And it is what lets a program remember and reuse information, instead of dealing only in fixed, one-off words. Storing values only becomes powerful when you start using them together, and 82112, combining and computing with them. Let us see how. Because a variable stands in for its value, you can use variables anywhere you would use the value itself. Store price equals 100 and quantity equals 3. And you can write total equals price times quantity. Python looks up each variable, does the arithmetic, and stores the result N824 224 in the new variable total. You did not type T100 anywhere. The program computed it from the values you gave. That is the essence of programming, describing how to work out an answer, rather than knowing the answer in advance. This is exactly why variables beat fixed numbers. Change the quantity to 5. Run the program again, and total updates itself to 500 automatically, because it was defined in terms of the variables, not hardwired. One description, many answers. A program written with variables adapts to whatever data you feed it and it to a how, which, when you think about it, is the very thing that made machine learning possible. The same code, you can also combine text. If you have a name variable holding Sarah, you can join it with a greeting to build a message like AIN8220, hello Sarah, AA200, and if the name changes, the greeting changes with it. Whether you are working with numbers or with text, the idea is the same. Take the values your variables hold and put them together to produce something new. So the takeaway? Variables come alive when you use them together. NA212, computing a total from a price and a quantity, or building a message from a name and A212, because you describe the calculation once and it produces the right answer for whatever values the boxes currently hold. We have written code on the slide. Now let us talk about where you actually type it and how you make it run, because you have two simple options. The first is the interactive interpreter, often called the shell or REPL. Here, you type one line of Python, press enter, and see the result immediately NA212, then type the next. It is a conversation with Python. Ask, get an answer, ask again. This is perfect for experimenting, testing a small idea, or checking an 8200. What does this do? An 8200, because the feedback is instant. When you are learning, living in this interactive prompt is one of the fastest ways to build intuition. The second option is to write your instructions in a file and A212, a plain text file whose name ends in .py, which marks it as a Python program. You put all your lines in the file, save it, and then run the whole file at once. Python reads it from top to bottom and carries out every instruction in order. This is how read programs are written and kept, because a file can be saved, changed, and rerun any number of times and shared with others. The simple way to think about the two, the interactive shell, is for quick, throwaway experiments and learning by immediate feedback, while a .py file is for read programs you want to keep and run again. Most of your early practice will move fluidly between them and Ale200, trying an idea live in the shell, then saving the version that works into a file. So the takeaway, you run Python either line by line in the interactive shell, ideal for instant experiments, or all at once from a save.py file, which is how lasting programs are written, and A2012. And as a beginner, you will happily use both, the shell to explore and the file to keep. Now, the single most important mindset for a new programmer, because it will decide whether you enjoy this or dread it, errors are completely normal. When your code has a mistake, an A2012, a missing bracket, a misspelled word, a forgotten quotation mark, an A2012, Python does not crash silently or judge you. It stops and shows you an error message. And here is the reframe that changes everything. That message is not a scolding, it is help. Python is telling you what went wrong and, very often, exactly which line to look at. Every single programmer, from the first day to 20 years in, sees error messages constantly. They are not a sign of failure. They are an ordinary expected part of writing code. So the skill to build is not avoiding errors and HU112. That is impossible and HU112, but reading them calmly. When an error appears, do not panic and do not delete everything. Read the message. It usually names the type of problem and points to a line number. Go to that line, look closely, and the mistake is often small and obvious. Once you know where to look, a bracket that was never closed, a name spelled two different ways, a quote left open. The rhythm of all programming then is a simple loop. Write a little, run it, read what happens, an 82 hunto, a result or an error, an 82 hunto, fix or extend, and run again. You do not write a whole program perfectly and then run it once. You build it in small steps, checking constantly, and the errors along the way are just the checkpoints guiding you. Embrace that loop, and coding becomes a steady conversation rather than a high-stakes exam. So the takeaway, errors are a normal, universal part of programming. An error message is Python helping you by naming the problem and its line. And the real skill is calmly reading it and fixing one small thing at a time. And unto I do one. Light, run, write, fix, repeat. Let us put every piece together into one tiny but complete program so you can see how the ideas connect. Imagine 4 lines. First, name equals, in quotes, Sarah and A212 Olvo, a variable holding text. Second, age equals 20 and A212, a variable holding a number. Third, print of a message that joins the words, and A222, my name is an A222 on, with the name. Fourth, print of a message that joins an I2 find, next year, I will be an A2 I2 find with age +1. Run it, and the program greets you by name and correctly works out next year in 39, Sage and 8 LATNT 1, without you ever typing 21. In 4 short lines, you have used variables, text, a number, a calculation, and print. That is a real program. Now, notice what you could do with it. Change the name to your own and the age to yours, run it again, and it speaks about you instead, and 8112, the same instructions, new data, new result. That is not a toy property, it is the exact principle behind every serious program, including the AI systems we have studied. Write the logic once and let it work over whatever data it is given. And this is precisely why today matters for your AI journey. Every model you will ever train, every dataset you will ever load, every experiment you will ever run, you will express in lines of Python just like these, and A200 qual, variables holding data, functions doing work, results printed out and checked. The gap between this 4-line program and a machine learning script is real, but it is a gap of vocabulary and practice, not of nature. You have already written code that has the same shape. So the takeaway, a handful of lines, an A212 valve, variables, a calculation, and print, an A212 valve, already make a genuine program that adapts to its data. And that very shape, write the logic once and run it over data, is the foundation everything in AI is built on. Let us gather the whole class in one breath. Python is the language of AI and A212, readable for beginners, dominant in machine learning, and backed by a huge ecosystem. A program is an ordered list of precise instructions the computer runs top to bottom, like a recipe. Print is a function that displays whatever you put in its brackets, with text wrapped in quotes as a string. A variable is a named box that stores a value so you can reuse it by its label. Variables come alive when you use them together, and A25 on, computing a total, or building a message, and A25 on, so one description serves any data. And errors are normal, read the message, fix one small thing, and run again. Next class, an ET or 12, numbers, text, and booleans, the basic types your data is made of. One idea at a time. So that is your first